Okay, so those are some tools. We'll go through processing text. I want to make sure I get through this since we have about 8 minutes. So processing steps. So note that I have this package NLTK, which I think is already in the Learn environment, so you guys shouldn't have to install it, but normally you would have to install it. So I have this NLTK. I have this data set right here, which is basically A Christmas Carol. So this is a freely available text online through the Gutenberg project. So I was able to kind of take this and save it, and it's just a text file, so it doesn't take up too much information. But I'm only gonna get the first 500 lines, so this is just reading through the data stuff. Note that this is actually using, with this with open, and this next part is using a generator. So I don't have to worry about, like, it ending basically, and this will get basically the first 500 lines. So if I run this now, this is a list, and then each element in the list is a separate line. So note, for example, one of the lines is just a new character and stuff, and you can see here, a lot of this stuff is just basically like metadata about the first part. But then as we get further into it, you can actually see the real story going on through here. So obviously this is kind of like dirty data. It's like it's got some extra junk that we really don't need for an NLP kind of stuff. So one thing we can do, first of all, is join it all together to make one like giant list, or not giant list, one giant string of these first 500 lines. So if I run this now, you can see now it looks much more like how we would expect to read it through. So you can see here, for example, the first bit, it's just all a bunch of metadata. And then as we go forward through here, we can actually see more of the actual story. Okay. Cool. And then I do things, for example, you can do a dot split. So this one, for example, this would actually split it now. So now we have this whole big long text. I can actually split it by the individual words. So now I can actually keep every individual word through here. And it's in list of order of appearance, but this can be more useful essentially to process it. In general, though, it just depends on what you're going to do. If you want to keep more sentence structure, you might not want to split it by word. You're going to split it up by sentences and stuff. Okay, so that's kind of like overall how you would read this data in. I'm not going to dwell on that too much. Note that the cleaning part, basically we can use regex and beautiful soup if you're having like HTML data to get rid of the extra junk. So note, for example, like this junk right here, like I probably don't need this. Right, you might want to use regex to kind of get rid of some extra, words and stuff like this. So you see like this URL, which is not going to be important for a Christmas Carol since URLs didn't really exist back then. So anyway, things to kind of consider. So this is where we go into normalization, tokenization, stop word removal, stemming, and lemmatization. We'll see if we'll get through this part. But normalization. So normalization, basically, the idea is to normalize it. It's basically to make it like consistent, right? So first, basically getting rid of capitalization, right? We don't need capitalization. So we make everything, and technically, usually what we do is we just make everything lowercase, which makes sense. Like capitalization really doesn't give any extra information that's going to be useful in natural language processing. At best, it gives us information where we're just reading, but you could probably imagine most of capitalization in American English is, well, just English in general, is probably kind of redundant. You don't necessarily need it. Okay, and the next part is getting rid of punctuation. Note that it's not always the best thing to get rid of punctuation, but depending on the task, especially if it's about a document as a whole, it makes sense to get rid of punctuation. You might want to keep it depending if you're doing something like, let's say, other things like if you process it maybe word for word and you want to see how the exclamation point kind of affects other things, it's possible to keep it. But in general, usually you'll get rid of punctuation, and that's a pretty common practice. Here I'm just using regex here, basically saying everything that's not an A through Z, lowercase and capital, or a number. Okay. So you can see here, if I look at this now, basically it gets rid of that extra junk. You can see like that UEF here is gotten rid of. And we can get a little more cleaner stuff. Note that it's still not perfect, right? But it's getting a lot better right here. Okay. So this is kind of the way we clean it. So you can imagine building up these different parts. It's usually better to just use something called tokenization. So tokenization, these tools usually incorporate a lot of this extra stuff. So you can actually build these in the tokenization. So you don't have to split this all yourself and make it clean. Turns out there's a lot of different ways you can tokenize your data. For example, you can do it by sentences. So you can split up by sentences, and you can actually find, where those punctuations happen, and it'll identify what is a sentence. So these are kind of tools that are already built into NLTK. There's also like word tokenize, which we'll use here in a second. Oops. There's also regex tokenizer, so you can actually define what is going to be counted as a token with regex. And what's really cool, you can also use a very specialized one, for example, a tweet tokenizer. So if you are reading tweets, for example, you can actually use that tweet, because obviously, if you know about Twitter, is that things like hashtags and ats and stuff like that are special to tweets, and those should be considered something separate than just simply just getting rid of the at symbol or getting rid of the hashtag. Those might be important by themselves. So you can also build up your own tokenizer as well through NLTK. In this case, we'll just use the word tokenizer from those words right here. Note that I'm just using the text clean here just because I got rid of some extra stuff just so it makes it easy for us. And you can see, for example, we have all our words now essentially put into this part. So we can see there's still some things in here that are not words. I think I just saw 0. So you can see these are best breaking up into different parts. Okay. Sound good so far? Okay. Next part, basically stop word removal. So remember removing the kind of like extra like redundant words or words that don't really mean that much. They're basically just common words that we just don't really need that. It doesn't give that much more information. So note that you likely will remove stop words, but it is dependent on the task, right? There are cases where you might want to keep them in there. But in general, for most NLP tasks, you're going to remove stop words. So NLP actually has a definition of all these stop words already in here. You can obviously add to this list or, see other words. For example, if there's very common words that or phrases that are used in whatever, set that you're doing. I'm trying to think of good examples, but I can't right now. But you can think of like certain communities using certain words over and over again that are really redundant and don't necessarily need, can be interesting. But also know that sometimes those stop words or other specialized parts can be really useful. One example of this I think is really cool is there was a data set or a model that was trained on Reddit. And I don't know if you guys are familiar with Reddit and like how they do stuff. But one thing they can do is like too long didn't read, right? TLDR. One thing they had with text generation is that they basically fed it the data through there and then put in TLDR. And then it would do a summary based on whatever was previously done. So you can actually use some of these advantages too to kind of like play around with some extra stuff. So no, it just depends on the task. But in this case, we're going to remove all these stop words here, and then I can just go ahead and run this guy. You can see it's just a list comprehension for W and words and Christmas Carol tokens. So we already tokenized it. And just saying if W is not in English words, then we're going to keep it. So you can see there, we go ahead and run that. And now we can get rid of all the I's and me's and stuff like that that really are redundant. We don't necessarily need to have that by itself, but maybe in some cases you might want to keep them. Okay. All right. All right. So I have stemming lemmatization. I see technically we're at like time. Would you guys be cool? I think at most 5 extra minutes. Okay, cool. I just want to check with you guys. All right. So next part is stemming. So this stemming and lemmatization is going to be going deeper and say, okay, like we have our words broken up into parts. We got rid of the capitalization. We got rid of any punctuations and stuff like this. Now what we want to do is like I mentioned about go and went are very similar words in that sense of like what they mean. So it makes sense for us to kind of keep them together. Also think of like, books and book. Like there's not really a difference in context of what that means. So we might want to just say shorten it to book. So stemming basically allows us to kind of reduce it to a root word. Now, note that this means that we can reduce complexity, so we don't have repetition of the same word over and over and over again. It's a fast and crude method. So note that like basically not all stemmed words are actually words. So you'll see things, for example, it'll get rid of S's at the end. And maybe, for example, like, I don't know if it actually changes, but like say Charles, and it'll get down Charles, and so it'll go down to Charles. And technically it's not a real word, but it will like be a definition, like a word, but restriction and restrictions are really the same word. There's some other, different stemming parts, getting rid of ED, for example, at the end of a word. So you might see something like included, you'll get just include without the E. So those are typical things that would happen. And that's okay. We don't need it to be real words. We just need to have the same context so we can identify each part. What's nice is that it's really fast and crude, but of course you don't have real words. So just kind of be aware of that stuff. So if we do this now, we can see a little bit like, oh, there's include right there. So you can see it got rid of the ED. And then let's see if it got, you see Christmas versus Christmas. So it got rid of the S's. You can see, oh, Charles ES. So it got rid of ES because ES is a very common ending and stuff like that. So you can see some very quick stuff where it's doing this very, very quickly, some basic rules, which make maybe some of these things are not actual words, but they'll at least be, I don't know actually what that word was to begin with. Oh, anyone. So you can see here a little bit. Some of the rules in here might make non-words and stuff like this, but it's a very quick and fast thing for you to be able to do. So
you want to do that even though it makes the words not real?
Yeah, it's kind of like saying word one, like word one, word two, word three. You don't really care about the word, like the spelling itself. You just care about, is it the same meaning of the word?
Okay.
So in a lot of cases, this is perfectly fine.
Okay.
Mhm. But of course, it depends on your task, right? If you want to know what the word is, it might be difficult to kind of go backwards, or if you have a lot of weird misspellings of words, or this is only for English, for example. Note that, for example, you can change this depending on what kind of stemmer you have. It might have different rules. Okay. Kind of like the converse, not kind of converse, but like another solution to this is lemmatization, which uses dictionaries to map the words. So note that like stemming is not going to change go to went, right? It's not going to be able to know how to do that. But we can actually use a dictionary of words to actually map them over. So what's nice is that it keeps an actual word. It tends to be slower because it's got to go through a dictionary. And also you have to have a dictionary of words that you can transform over to each other. So you have to make sure you have it specific to that language or even possibly that community. Or for example, if you have something that's more non-traditional English, or at least not like standard English, you know, I put those in quotes because there's no standard English. But like the idea is like if you have someone who's using different kind of terms and stuff like that, that's consistent throughout the population or whatever community you're using, you want to use that. So one kind of common one that, you know, you might think of is like ain't. Like ain't nowadays is so common, it's probably in this dictionary itself, but you might consider that like not proper English. If you didn't consider ain't in there, you might not have realized, oh, ain't and isn't is really the same thing. So those are things to consider. But you can see lemmatization here. This will take, in this case, it looks like just the token, so before this stemming. And you can see here, for example, they all end up being real words and stuff like this. I'm not going to go through it, but you can probably find the words that are very similar to each other and stuff like this, that like go and went and stuff like that. But anyway, I'm not going to go through it right now.
So after you, I mean, I'm seeing that like Christmas is repeated in here.
Mhm.
After you lemmatize, would you then go through and take the set of words?
Yeah, it depends what you're going to do next.
Sure.
So
Okay.
if you keep, this is still like in the order that it occurred, but you
Right.
might next say, okay, I just want to see how often these occur. And you might do something like for featured engineering, like make it more set or count the occurrences that happen.
Right. Okay.
That could be important for your use case.
Cool.
Okay. So that's kind of overall like what you can do. I'm going to put one last thing here, part of speech, POS tagging. This is, you'll find this a lot in NLTK. And so basically the idea here is that you can label each word and saying, is it a part, what part of speech it is? Is it a noun? Is it an adjective? Is it the object? Is it the subject? Those kind of things. And you can actually create, I'm not going to run this part because I already ran this, but basically you can create these kind of like trees essentially of grammar. So the curriculum kind of talks about a whole bunch of this. I'm not going to go into full details on this because there's a whole, you can talk about a whole time like about just grammar itself. Note though that basically, even though this can be really useful, it is tough to get data sets that already have this labeled on the entire corpus, and corpus meaning like a set of text. And so this process takes a lot of effort. It's extremely error prone. Think of basically assigning people labeling, you know, like I don't know if you guys did this back in grade school, but like doing like tree diagrams of parts of speech, or labeling like, oh, this is a noun, this is an adjective and stuff like that. You can imagine this might make some mistakes. So, and also we get some of these interesting ambiguities, which I show this famous example. I shot an elephant in my pajamas, which is really common, but know that there are other strategies that we can use, like HMMs, hidden Markov models, and recurrent neural networks, RNNs. But anyway, you can see here, here's a mapping of essentially a tree here. And this is like the classic, I shot an elephant in my pajamas, which could mean I shot an elephant while I was in my pajamas. Or you can think I shot an elephant and that elephant was wearing my pajamas. So you can interpret that in different ways and stuff like that. So yeah, anyway, that's overall. My dog heard that we're done. But yeah, any quick questions before I end it here?
So what we do with this information then is make a choice about which pre-processing methods we think are gonna be most useful and solve our problem, right? Like this is a menu of choices and we select. Okay.
And that's exactly right. And you can modify a lot of these things, like the tokenization, the lemmatization, the stemming. You can have different ways of doing these things. So we can say, oh, I'm stemming these words, but you have to decide what are the rule cases that you're going to use. And that might be dependent on your task or the data that you actually collect. Okay.
And the pre-processing here is like sort of similar to cleaning, right?
Yeah, it's basically like a form of cleaning, essentially.
Yeah.
Yeah, cool. All right, so I'll go to end it here then. All right.